Okay, so here is the plan. Okay, the more that we get through today, the less we have to get through later in the week without me even being here. So, let's look at your notes from yesterday. We did one example. We're going to hopefully do 2 more today, okay? So, the next one, and also if we don't at least get through 2 of these, your homework's going to be really confusing. So, are you ready to learn?
Yeah.
Okay.
Let's get started.
Number 2, this is adding on to yesterday's notes. Okay, you are going to prove that the derivative of f of x is the reciprocal of f inverse of x. Okay? Which, remember, is the exact same instructions that are on your homework, and we got through one example of this yesterday. Hopefully we'll get through both of them today. Okay? So the next one that we're going to look at is going to be y equals the square root of 4x plus 2 at x equals 9. Okay, now I'm going to write out the notes for this, or the steps for this first one, so that hopefully when you do your homework you can follow along. Step number 1, I need to complete the ordered pair. Complete ordered pair. So what am I going to do with 9? Plug it in. So I have y equals 4 times 9 under the square root plus 2. Okay, very good. It is 8 because it's root 36, which is 6, and then plus 2 gives me 8. Now, you don't have to show every step on that. If you could have done some of that in your head, totally fine. Okay, so what's my ordered pair now?
8.
Good. Good job, Yoshi. Okay, from there, I'm going to take the derivative. And in order for me to take the derivative of root 4x, I'm going to need to do a rewrite. So I'm going to put here RW. Remember, that stands for rewrite. And then what is a square root as a power? What fraction? To the 1/2. So it's 4x to the half plus 2. Now remember, that's not the derivative. I'm rewriting to take the derivative. Okay, so y prime equals, take your 1/2, times it down to the front. What's the power on 4x now?
Negative 1/2.
Chain rule, times by the derivative of the core. What's the derivative of 4x?
4.
Times 4. What about the plus 2?
0.
0. Yeah, well then I'm going to multiply these. Yeah, so what is half of 4? 2. So really I have 2, 4x to the minus 1/2. Everybody good with that? Now, how could I rewrite that? Because I'm going to have to plug into it, and I don't want to do it later. Well, you can't actually multiply into this because it's in an exponent. Where can that go? On the bottom, because of the negative, and the 1/2 turns it into a root. So it's a square root, but on the bottom. So it'd be 2 over square root 4x. Good? Now, that is the slope at any point. Where do I want the slope?
At 9 and 8.
At 9, 8. So I'm going to find the slope of the tangent line at 9, 8. So that means I'm plugging in my x value, which is a 9. What is y prime of 9? Well, it'd be 2 over the square root of 4 times 9. Oh, what?
No, it's not.
4 times 9 is 36, right?
Third.
So that'd be the square root of 36, which is 6. 2 over 6 is a third.
Yes, ma'am.
Okay, so my first equation, my original function, the slope is a third. What reciprocal am I expecting over here if I do everything right? 3. If that doesn't happen, you didn't prove it. Don't change the sign, just flip it. Only reciprocal. What is it when you change the sign and you flip it?
Inverse.
Perpendicular. Remember? Inverse, you only flip. Perpendicular is when you change the sign and flip. Okay? You don't change the sign. I mean, it's in you review it in geometry. Okay, so come back up to the top. Okay, let's do our steps on the other side. So, I completed the ordered pair. I took the derivative, and then I found the slope at my point. On the other side, you need to find the inverse. So, do we remember from yesterday how to find the inverse?
Yeah.
Swap x and y.
Swap x and y, so it's x equals root 4y plus 2. Okay, then what do I do from there? No, you gotta solve for y, so what do I do from there? Minus the 2. So I have root 4y equals x minus 2.
So you can square it.
Square it. And when I square the x minus 2, remember you gotta group it.
Parentheses.
Okay, so now I just have a 4y left over.
Over 4.
And then I'll put a 1/4 on the other side to cancel that out. So my final answer is y equals a 4th x minus 2 quantity squared. So that's my equation. Now from here, after I find my inverse, I need to take its derivative. So that's the same as the step on the other side. When I take the derivative, I'm going to need to do chain rule. So what is 2 times a 4th? 1/2, or 2/4, which is going to reduce to a half either way, right? So I have a half in the front. Then when I take away 1 from the squared, what's my power now? 1, so I don't have to write that. You can if you want to. Okay, and then times, what's the derivative of the core in the middle?
X.
The derivative of x, so it's just a 1. Yeah, so really, I didn't have to write this top one or this side one, so really, I just have a half of x minus 2. Now, your next and final step is to find the slope at that point. But what do you hopefully remember from yesterday happens to that point for the inverse? It flips around. So instead of being at 9, 8, for the inverse, the domain and range are backwards, so it's actually an 8, 9. And so I'm going to plug in an 8, boom, right here. So I want y prime at 8. Well, that's half of 8 minus 2. 8 minus 2 is 6. What's half of 6?
4.
3. And are they reciprocal?
Yeah.
Good. Okay? So that's what you're showing on your homework.
Okay.
Okay. All right, we have one more with a cubic root. Okay?
Can I get a drink of water?
Oh, I'm good now.
Good?
No, you see, this is going too fast.
You're going too slow, fam. Not your earphones.
Oh, I'm listening. I know everything.
Yesterday I really yelled at you. Did that hurt your feelings?
That just made me so.
You yelled at him when I was a kid?
I
What
did.
did she yell at?
He said, "You're going too fast." I was like, "Because you! I texted on your phone."
Oh, and I said I was on focus because I haven't ate in this car.
Well, maybe don't be on your phone. You can check your focus whenever you want. Boy.
I had to check it out.
Okay, may I change it now? Are we good?
Yeah.
On the lake.
Mommy, uh-oh. Remember that song? Okay, next one. 6x minus 10. Cubic root, and we're doing it at x equals 3. Yep, do it. Okay, so my first step is what, Ebenezer? Huh?
Plug in 3.
Yep, plug in 3 to complete the ordered pair. So I plug my 3 in here, then really I want the cubic root. What is 6 times 3? 18 minus 10. 18 minus 10 is cubic root 8. Cubic root 8 is 2. So what's my point? 3, 2. Okay, next step, I take the derivative. Okay, when I take the derivative, I'm going to need an RW. What's that stand for? Rewrite. What's a cubic root the same as? Not a half.
1/3.
A third. So that's a 6x minus 10 to the 1/3. Okay, so take the derivative. Y prime is going to be a 1/3 down to the front. What is the new power on 6x minus 10 if I had a third and I minus 3/3, which is really just a 1? Negative 2/3. Times by, what's the derivative of my core for chain rule? Times 6. Last time it was a times 1, so it didn't matter if you forgot it, but here it would matter. Okay, then what is a third of 6? Really, that's just a 2. If you're confused by that, remember a third just means divide by 3. So 6 divided by 3 is 2. And then if my 6x minus 10 has a negative 2/3 on it, where does that really belong? On the bottom. And if it's a 2/3, it's a squared, that's a cubic root as well. So I would have this, 2 over cubic root 6x minus 10 squared. Now, depending on who you've had for pre-cal, I don't know if they talked about this or not, it does not matter if you square first or you cubic root first. Technically, both are right, but it will be easier to cubic root first. So let's plug in our point. What's our point? Okay, I'm going to find the slope at 3, 2, which means what number am I plugging in?
When do you flip it?
Not till the other side. So we're plugging in our 3. What do I get inside the root on the bottom if it's a 6 times 3 here again?
18.
18, and then what's 18 minus 10?
8.
8. So really, I have 2 over,
1/2.
hang on. Okay, it's the cubic root of 8, and then squared. Now, you can square first, but just cubic root first. What's the cubic root of 8? 2. What's 2 squared? And then 2 out of 4, as Yoshi said, is a half. I thought you were just saying random crap. You were saying the answer. I was like, where are you getting a half from? But you got it. You were right. Okay, now, if the left side comes out to a half, what should the right side come out to? 2. If that doesn't happen, you mess something up. So come back up to the top. What do we do first?
Inverse, switch it up.
We need the inverse. Switch your x and your y. So I got a half on the left side. Going to find my inverse, which is going to be x equals cubic root 6y minus 10. What do we do first? Add the 10 over? No. What do you do first? Cube. Okay, you cannot add a 10 if it's inside a root. That doesn't count. So I have x cubed equals, my cubic and my cubic root cross out. 6y minus 10 equals x cubed. Next step. Okay? Okay, so I need to get rid of the minus 10. How do I do it though? Plus the 10. So it's x cubed plus 10 and then divide by 6. Now I'm going to multiply by a 6th instead, but we're fine with that's the same, right?
Why do you want to multiply by 6?
Because I'm going to distribute it. I just think to me that looks easier, but you could do it either way. So a 6th of x cubed is a 6th x cubed. Just leave that alone. And then a 6th of 10 is 10/6. Now, even though you don't like that number probably, it's a constant. What's going to happen to it when I take the derivative? It's going to go away anyway, right? Even though it's a 10 over 6, nobody cares. When I take the derivative, that's going to go away anyway. So next we're taking the derivative. What is y prime if I have a 6th x third?
1/3.
What is a 6th of 3? A half x squared. And then what do we say about this constant? 0. Then from there, I take the derivative and I plug in the x value for the inverse. If this point is 3, 2, good. I want the slope at 2, 3. Which means I'm plugging in the 2. So y prime at 2 equals a half of 2 squared, which is half of 4, which is 2. And now look at them. Little reciprocal buddies. Good?
Miss, yes.
Look, we got there too.
Okay, good. No, now we're going on to inverse trig.
Inverse
Okay.
trig.
Yep. Okay, now listen, my plan was, okay, to go through this whole pink sheet, but since we started off behind, we're only going to do a couple of them for you to get the idea. Did you have a question? Okay, so for a regular inverse, or for a regular trig function, okay, for a regular trig function, your point is a theta and then a number. So what that means is that I'm going to tell you theta, and then you're going to tell me the number. So ready for fun? What is the sine of pi thirds? Sine pi thirds, whoop, root 3 over 2. What is the cosine of pi fourths? Root 2 over 2. Okay, so I tell you the angle, you tell me the number, yeah? For trig, it's backwards when it's inverse. So I'm going to tell you the number, you're going to tell me the theta. So ready? Real easy. Okay, look at your hand. I want the inverse sine of the number, you're going to tell me the theta. So if I want inverse sine of root 3 over 2, here's what you do, watch. 1, 2, 3 sine fingers on bottom, fold the next one. What angle's that? Pi thirds is the answer. Okay, don't make it hard. Let's say I want inverse cosine of a half. I want 1 cosine finger. I fold the next finger. What would that be? Pi thirds. Okay, ready? What if I want the sine of 1? Then I want all my fingers on the bottom, so I'd want the thumb, which is pi halves. Okay, one more time, listen. Okay, or if you like the unit circle, do the unit circle. So if I'm here, look.
Nope. See, I was understanding something and now I don't.
I'm lost now. Like,
Okay, shh. If you in trig, in pre-cal, if you memorize the unit circle, your x is a cosine, your y is a sine. Okay, shh. So if I want sine to be 1, sine is my y value. When is my y value 1? At what angle is this? Pi halves is the answer. So I give you the number that I want, you give me the angle. Now let's say I want cosine to be 1. Okay, well cosine is my x value. When is cosine 1? At 0 or 2 pi. Okay?
Or 4 pi.
Or 4 pi. Now we're going to just go 0 to 2 pi, otherwise you have too many repetitions, but you're right. Okay, let's go down to this one, D. I want inverse sine of a half. Okay, very good. Pi over 6 is right. Here's what you're going to do though. Here's my 1 sine finger that I want if you do hand trig. Folding the next one, what finger is that? Pi 6.
This is 0.
Okay? Yes, we are going to find the other one in a
Can I
second.
get the pink sheet?
Yeah, it was right there. Okay, now listen. Your sine is going to be a half in 2 quadrants. Where else, all students take calculus, where else is sine going to come out to be positive? Which letter?
Oh, hey.
All pi 6, and where else? Sine. So if this is 6 pi 6, what is that? 5 pi 6.
Yeah,
Okay? Alright, let's go to the next one. I want inverse cosine root 3 over 2. I want 3 cosine fingers. Fold the next one. That's still pi 6. But where does cosine come out positive? What other quadrant?
11, negative 11.
Okay, give me the letter.
4.
The C one. Okay, quadrant 4. And if this is 12 pi 6, and I rewind 1, that's 11 pi 6.
I'm
Okay.
confused.
Now listen, for my people that got it, okay, you work ahead, okay? But we have to be patient for everybody so that we don't go on without it.
I want to work with you.
Okay, so 5 pi 6, pi 6, yes.
I felt like I was gonna do.
I have a question.
Hey,
I have a question.
yes.
So you look at let's say.
Hey, we don't have time for this. What? What's your question?
Oh yeah. So if we're looking for like let's say B, right?
Yes?
Sine, right? We got pi over 6. Then we got 5 over 6 because it's halves.
Because that, okay, so remember guys that your letters here tell you which trig function is positive in that quadrant. So if I want, if I want sine to be a half, that's a, hey, but I'm talking to you, you're looking at him. Okay, a half, then I want to be in the all positive, pi 6, or the sine positive. So if this is pi, that's 6 out of 6. Then I need to back up 1 to get to 5 out of 6
Yeah,
pi.
that's what I'm saying.
Yes. Then for this one, if I want cosine to be positive, I got to be down here. So that's 6 out of 6. That's 12 out of 6. Back up 1. 11 out of 6. So this is 12 minus 1 to keep me in cosine. 11. Okay, we're going to keep going. Next one here. This one. I want cosine to be a half. Okay?
So you go
I
like-
want 1 cosine. Fold the next one. Pi thirds. Okay, now put a pi thirds here. Too fast.
She won't be here.
I love to tutor though.
Are you gonna have like a tutoring day?
Over Thanksgiving.
Can you
Jennifer,
record
hit me up.
yourself before you leave tomorrow? Can you
Me
record
too.
yourself
It's like
at
an
home?
actual day.
Okay, hold on. Okay, this is a half. Where else is cosine positive? A, S, T, C,
Hey,
and C. So if this is 3 out of 3, what's double that?
6.
6 out of 3 minus 1 is
5 hours.
5
I
pi
got this now. I
thirds.
got this.
Okay, good. You'll get it. It's okay. Okay, let's go down to the next row. Let's do K.
I just need to know how to do the circle. I don't know the circle.
Okay. Cosine negative root 2 over 2. What finger is cosine going to have 2 on top? Pi fourths, yeah? This is pi fourths. Now, I need cosine to be negative. So which quadrants do I want? I want the S and the T. Now, if it's pi fourths, what's this axis? 4 pi fourths. So if I minus 1 to put me in S, what's that? 3 pi fourths.
It makes sense.
And then if I add 1, 5 pi fourths.
Are we gonna have to put all these like values into equations?
It's not on the test a ton, but we're about to do it in your notes. That's why we're practicing. Okay, so we're going to do one more. Ready? This one. Last one. Okay, I want sine to have 3 fingers below. 1, 2, 3. Fold it down. What is it? Pi thirds. Now, I want sine to come out negative. Can I keep pi thirds as an answer? No. Where is sine going to come out negative in my chart?
5 pi thirds.
T and C. So if this is 3 pi thirds, what is plus 1?
4 pi thirds. 5 pi thirds.
And then if I go to here, that'd be 6 pi thirds. Rewind 1, that'd be 5 pi thirds. Why isn't it what? Because if I'm at 5 pi thirds, that puts me in cosine. So all the way around is 6 thirds, because that'd be 2 pi. So if I back up 1, that puts me in cosine, and cosine, sine would come out negative. Because cosine's the only guy that's positive in that quadrant. Okay, now we need to do the tans.
Because sine has to be negative.
Yes, because sine has to be negative a half is the answer.
I don't know.
Does that answer your question or no, Glenn? So like, look, this is the y value that I want. So if sine is my y value, then I gotta be below the x-axis.
Pi over 4.
Does that help?
Pi over
Yeah, I get
4.
Okay, alright. So last 2 that we're gonna do tan, these, actually we'll do these 3 right here. Okay, if I want tan to be 1, tan is the same as sine over cosine. If sine over cosine needs to divide to be 1, then what do they have to be in relation to each other? Equal, right? Because if I do sine divided by cosine and they're the same, what am I going to get? 1. So what angle or what finger are sine and cosine equal at? Pi fourths. Now, I want tan to be positive 1. So pi fourths is here. Where else is tan positive? Which letter?
T.
T. So if this is 4 out of 4, what would that be? Okay, so pi fourths, 5 pi fourths.
I wish I understand.
Okay, next one. I want tan to come out to be negative 1. Which quadrants is tan negative in? 2 and 4, S and C. If this is 4 pi fourths, and I rewind 1, that's 3 pi fourths. Now double it, this is 8 pi fourths. So if I minus 1, that's...
Oh, Miss Jordan, you made this easier.
It is easy?
No,
Easier,
no,
maybe?
no.
The math tree.
Okay, now the last one, inverse tan of 0. Okay, remember that if sine over cosine needs to divide to be 0, which of them needs to be 0, the top or the bottom? What would happen if the bottom was 0?
Undefined.
Undefined. So when is sine going to come out to be 0? 0, 2 pi, one more. Pi. Make sense?
Yeah, boy.
Okay.
Do the last three. You already did almost all.
Okay, you do them.
No, you do
Wait, no, you doing this.
Okay, when is cosine negative 1? What angle?
That's
Why
right
you
here.
skip this like
Like this. Look,
Why you
in the
skip
middle.
negative?
It's hard.
I don't understand.
Get you.
Oh my.
Pi, right? When is cosine going to be 1 at 0? But I don't want 1, I want negative 1. So instead of being here, I have to be here at pi. Yeah?
Sure.
Yeah. Okay, look at G. Inverse tan. Okay, here's the deal with root 3. If you want root 3, sine over cosine needs to be root 3 over 2 divided by 1 over 2. Here's why. If I do root 3 over 2 and I flip, what's going to happen to the 2's? They're going to cancel out. So I need the angle where sine comes out to root 3 over 2 and cosine comes out to be a half, so that when I flip by 2 over 1, the 2's cross out.
But what is negative?
We'll do the sign in a second. I'm just picking the angle right now.
So it's pi third.
So it'd be pi thirds, because sine is root 3 over 2, cosine is 1 over 2. Now, if I pick pi thirds, is tangent going to come out negative?
No.
No. Where is tangent going to come out negative?
T and S. No, S and C.
Okay, so if this is 3 pi thirds, because that's the angle I picked.
2 pi thirds and
2
5 pi thirds.
and 5.
So those are the answers?
Yep.
Good job, James.
Okay, you have one left.
No, we don't.
Can you do it?
No, seriously.
Yes, you can.
Sine, so it's negative.
Sign being
Right here. Right
I don't
here.
miss. I still don't know what she did with
That's-
your fingers.
Yeah, right here.
The hand trick?
Yeah.
Then just do the unit
what
circle.
She just did. Like you said, go back 3. I don't know.
So if I want sine to be 3 fingers, 3 is on the bottom, 1, 2, 3, then I fold this one. And then what's my cosine? 1 half. What's my sine? Root 3 over 2.
Oh, I don't know why you did that. So you said side.
You got 3.
And then you put this finger
Yeah,
down.
so that I have root 3 over 2 for sine and 1 over 2 for cosine.
You see? 1.
No, because you're doing the first
Yeah.
and second quadrant.
This is sine. This is cosine. So 1.
Do you remember hand trick? You can do the unit circle.
This is 0. This is pi.
Yeah, pi halves.
6. Yeah, this pi 6, 4,
Yeah,
3.
and then you take square root of fingers over 2. So if I want 3 on the bottom, that's root 3 over 2. And then this is root 1 over 2, which is a half. Because if I want it to give me root 3, I need to have root 3 over 2 divided by 1 over 2. Here's why. What happens when I do that and I times by 2 over 1? What do I get? Root 3. Huh? For tangent, sine is on top. It's sine over cosine.
I'm talking about for your
Oh, sine's on bottom on your hand.
It's like sim. So how would you do? Like how would you do with your fingers?
For which one?
What
This
we
one?
do, yeah,
Okay, so how many sine fingers do I want?
3.
3. So 1, 2, 3, fold the next one.
Yeah.
What angle is that?
For sine, it's pi over 3.
Pi
Yeah.
thirds. Okay, now when else is sine positive? Here. So if that's 3 pi thirds, and I go backwards 1.
I need the circle tutoring again. Because I didn't.
Okay, so listen, I love to help with trig, but okay, keep in mind that this is not, it's not like if you can't do backwards trig, you're going to fail the AP test. So, we will go over this more later. We have to get through at least one example.
Let's go.
Okay, so let's go back to your notes. You've had a little reminder. The next thing that I need you to get out is your rules sheet for derivatives. Now, if you have lost yours, I only have one left, okay, but I will copy more, but you can look at mine or take a picture of it or I can send it to you on Remind. Okay, but all of these guys right here are your inverse trig derivatives. I would not memorize them. You get to use this on your semester exam all the way up until the AP test. However, the 3 that I have starred are the most important ones that you're most likely to see. So if you want to star 20, 21, and 22, those are the ones you're most likely to see on the AP test. What'd you say?
What does that stand for?
Arc and inverse are the same. So if you look down here, it says arc trig is the same as trig to the -1.
So
Okay,
it's
also,
trig to
did
the
Miss
negative
McDaniel use this one?
Yeah.
Okay, in college, you're more likely to see this one, but they're the same. They're just different notations for the
What's
same
college?
one. Okay? Did you say, I don't think we ever did that? No! Okay, so ready? Whew.
I don't believe in college. I don't think I'm going to college.
You can go to college.
I'll try.
Well, you gotta decide if you want to. Okay, so ready? We're gonna do a couple of practice derivatives. Okay, we're gonna do a couple of practice derivatives. You can label this inverse trig. So the first little practice we're gonna do is the derivative of inverse tan 4x. Okay, so ready? You're going to look at your rules sheet. I'll put mine up here. And I'm going to write the rule down on my paper. So if you have your sheet, what rule is inverse tan? Number 22. So I'm going to put number 22, d dx, inverse tan u, is u prime over 1 plus u squared. Okay, these are easy. You just have to know what your u is, what your u prime is. So my u is what's inside tan.
4x.
4x. If my u is 4x, what is u prime? Just a 4, and then I'm following this formula. So what do I put on top? What's my u prime? 4 over, what do I put on bottom?
Plus parentheses 4x squared.
Done.
That's it?
Yep. Okay, for your inverse trig, you're using your formula chart, and then you're just taking the derivative based on the formula that's given on your chart. Now, we're going to do another warm-up. Okay, let's say you want d dx of inverse sine of 3x. So, look on your little sheet.
Squared minus 4x minus 72.
Okay, inverse sine is rule number 20. And it says d dx inverse or arc sine of u equals u prime over 1 minus u squared under a square root.
So arc and the negative.
Yes, arc and inverse are the same. Arc you'll see a lot more commonly in college. The AP test uses inverse, but you should know they're the same. Okay? So from here, what is my u in the inverse sine equation that's given to you? What is your u prime? 3. Now I'm using my formula right here. U prime goes on top. What is it? 3 over square root 1 minus, and then my u is a 3x squared. What's wrong with that? Minus is there.
Oh, 3.
Something's wrong with it. My squared's in the wrong spot. That's wrong. Where should it be?
Outside.
Good. And now the difference is that if I write it like this on the AP test, usually they would write it like this. 1 minus 9x squared. Do you see how these are really the same? Okay, but you have to make sure if they put 3x squared like I did as an option, that's wrong. Because if I square 3x times 3x, you get 9x squared. Because you're squaring both the 3 and the x.
Was it squared the 3?
Yeah, so if I put my squared here, that's wrong. If I put it on the outside, it squares both of the inside terms. So for example, up here, how would I rewrite this one? That'd be 4 over 1 plus 16x squared. Okay, so just make sure that you're aware of that as kind of like a trick that they could do. Okay? So we have about enough time to do one. That's okay. All right, so are you ready for the first one?
Ready to cry.
I guess
No, you can do it.
21.
Am I gonna use this?
Oh, no, I hope I like
21.
physical therapy.
Okay, I'm turning it. Good?
Inverse.
Yeah.
Okay, our one example that we're going to get to. Okay, here we go. Your equation is going to be y equals inverse tan of 4x, and we're going to do it at x equals a fourth. So I tried to pick one that's not too hard. Your instructions are what we were doing at the beginning. Prove that the slope at one is the reciprocal of the slope at the other.
Would it be what?
Okay, so first thing I'm going to do is I'm going to complete my ordered pair. So I'm going to plug in complete ordered pair. So I'm going to plug in a fourth. So I want the inverse tan of 4 times a fourth, which is what you said, Yoshi? Inverse tan of 1. Now think about, if I want to get 1, sine and cosine have to be equal, so they divide to 1. Where did we say that happens? Pi fourth. Now, if you don't understand that, we can go over it in tutoring for forever, but that was your little pink sheet where you go backwards. So if I want tan to be 1, I need to be at pi fourths. So my ordered pair is a fourth, comma, pi fourths. Now, that should make sense to you why it's backwards, because that wasn't a regular tan, that was an inverse tan. Okay, from here, I'm going to take the derivative. I'm going to have to use my rules sheet. So if I want the derivative, y prime, look at your little notes. We already did the inverse tan on there. Okay, if I have y equals inverse tan 4x, what's my u? 4x. What's my u prime? Just a 4. And then I'm using my rules sheet here, which tells me that it's u prime over 1 plus u squared, right? So what would that be for this guy?
4 divided by 1 plus 4x squared.
Good. Now, what x am I plugging in? A fourth, right? So I'm plugging in my x value, so I found my derivative using my formula. Now I'm finding the slope at the point, a fourth, comma, pi fourths. I'm going to plug that in. And what do I get on the bottom? Inside the parentheses, if I plug in a fourth next to a 4, what's that really in there? Just a 1. What's 1 squared? What's 1 plus 1? So I have 4 over 1 plus 1, which is 4 divided by 2, which is 2. On the other side, what slope do I expect to get if my first derivative was 2? 1/2. If I don't get a half, we messed up, which we will. Okay, so ready? Other side.
We will.
We will get it right. We will not make a mistake. Okay, ready? Can I go up?
Yeah.
Okay. So at the top, I want you to switch your x and y. We're going to find the inverse.
Or you can go
Okay? So I'm going to let x equal, this is my inverse step,
to pi 4.
inverse tan of 4y. Now, this is something you may or may not remember. How do I cancel out an inverse tan? You take the
Derivative.
tan on both sides. And what happens when you tan an inverse tan? They cancel out. What's left over? 4y equals tan x. From there, how do I get rid of the 4? Good, so I have a fourth on this side. So y equals a fourth tan x. Your derivative sheet is out. What's the derivative of tan x? What's the derivative of tan? Secant squared. Now, this is the chain rule, but if it's just the x, I don't have to worry about that. So the derivative of tan is secant squared. And then what value am I plugging in? Do I plug in the fourth? What do I plug in? Pi fourths. So I want y prime at pi fourths, and then I'm going to put, that's the original y value, because It's an x value for the inverse. Okay, because remember, the point's always backwards. Now, how do I find secant? I find the cosine, and then I flip it, right? So, what is the cosine of pi fourths? Pi fourths is here, root 2 over 2. Then what is the secant? I know. Secant pi fourths would be 2 over root 2. And then what am I going to need to plug that into? It's going to be squared. So I'll have a fourth secant squared. 2 squared on the top, what do I get? 4. What's root 2 squared on the bottom? 2. 4 is crossed out, what'd you get? Woo! We did it!
Good job, Miss